Hey guys, in this video the lovely Mr. B is going to be taking you through working out the volume of pyramids, spheres and cones. There are going to be 15 different examples at 3 different levels and you can start this video wherever you want to. Timestamps are in the description below. You can move forwards at your own pace or backwards at your own pace if you're finding it too easy or if you're finding it too hard. And then when you want more questions to practice on your own, over on our website there are thousands of multiple choice questions for you and a ridiculously large workbook waiting for you.
We're going to find the volume of pyramids, cones and spheres, and we're going to start off with pyramids. Now the method to find a pyramid, and part of this might seem familiar, is firstly we are going to find the area of the kind of base here, the bottom face. Now this is a square-based pyramid. When you say a pyramid, you assume it's a square-based pyramid unless you're specifically told it's something else. And you can have hexagon-based pyramids or triangle-based pyramids. Those are usually known as tetrahedrons, but here we have square-based pyramids. So to find the area of the bottom, then it's going to be 11 multiplied by 11. The two measurements, the measurement highlighted now in green, the 11, and then the other side, these are actually at a right angle to each other. They don't look like a right angle because of this perspective. And given it's a square base, then they're both going to be the same size. And that's going to give us an answer of 121. So we found the area of the base. Now, if this was the prism, that square will go all the way through the shape and the top face would also be a square. And you could multiply by the height and find the volume of a cuboid or cube. Now, with a pyramid, that doesn't happen. That square doesn't go all the way through the shape because you have a point at the top. So we are going to do something different. But our next step, it is going to be exactly the same as finding the volume of a prism because we are going to multiply by this height here. Now again, with perspective and with different rotations, it can be difficult to say what exactly to multiply by here. So what I've just highlighted in pink, it is a right angle to that base face. So we're going to take the 121, we're going to multiply it by the 11, and that should give us 1,331. And then that would be the volume of a cube with that measurement. Now, obviously, this isn't a cube, but we've got the area, the volume of a cube. So what do we do next? Well, interestingly enough, it turns out that pyramids are 1/3 the size of a cube with the same measurements. So we're going to take the 1,331, and because pyramids are 1/3 of the size of a prism, we are going to divide by 3. Now, this would be a calculator question, so dividing that by 3, we get an answer. I'm getting 443.6 recurring. And if you divide them by 3, especially whole numbers, then getting recurring symbols is going to be quite common. Then look at the units. This is in meters. And as usual with volume, we multiplied 3 measurements together. We multiply the two 11 meters on the base and then the 11 meters for the height. So 3 sets of meters multiplied together will give you a cube symbol, a little 3 on the meters. And to sum up, what we've done is we found the volume of a prism using methods we've used before, but then we've divided by 3 because pyramids are 1/3 the size of a prism. So using that method on question 2, we're going to identify the base area first. In a square-based pyramid, this will be a square. So if the measurement of one side is 13.5, then the other side will also be 13.5. And so we're just finding the area of a square. I type that into a calculator, and you should get 182.25. So we've got the area of the base face of the pyramid. Next, we'll multiply that by the height. So we're finding the area of a cuboid with these measurements. So we're multiplying by 13.2. And on a calculator, that should give you 2,405.7. For your final step, you have to understand that this isn't a cuboid, it's a pyramid, and it's 1/3 of the size. So take the previous answer, divide it by 3, type it into a calculator, and that's giving me a final answer of 801.9. And our units were in meters, and it's a volume, so it's cubed. Moving on to question 3. So we've got the square base of the pyramid. That's got a measurement of 10 meters. So 10 times 10 is 100. Once we've found the area of the square base, we're going to take that number and we're going to multiply it by the height of the pyramid, which is 13 meters. And again, the heights are going to be measurements that are at a right angle to the base of the pyramid, just in case it's rotated around in an odd position. So that's going to give us 1300. And then for the final answer, because again, remembering when you do the area of one of the faces and you multiply it by the height, you get in the area, the volume even of a prism. We want a pyramid, so we have to divide it by 3. So 1300 divided by 3, and use the calculator, that should give you 433.3 recurring. And the units, again, are in meters cubed. Question 4, following the same method, identify the base, find the area of it. So for a square, multiply one of the sides by itself, square one of the sides. That should give you 144. Then we're going to multiply that by the height. So we're going to take 144, we're going to multiply it by 16 for the height, and that should give us 2,304. Final thing, remember for a pyramid, need to divide by 3. So take the number, divide it by 3 on your calculator, and that's going to give us a final answer of 768, and our units were in meters cubed. Now for the final pyramid question, again we're going to identify the base of the pyramid. We're going to find the area of the base first, and in a square base pyramid, that would be 16 times 16. That's going to give you 256. I'm going to take the area of the base, and I'm going to multiply it by the height, which is 13 meters. That should give us 3,328. And then for our final step, we're going to take that number, I'm going to divide it by 3 for the volume of the pyramid. That's going to give us 1,109.3 recurring. And our units again are in meters cubed. So the volume of a pyramid is the same as the volume of a prism using the same base, divided by 3. Pyramids are a third of the size of an equivalent prism. Moving on to cones, you'll notice a similarity between cones and pyramids, as they both end with a point at the top of the shape. Now, cones are not pyramids. The definition of a pyramid is technically going to be talking about a straight-edged shape, whereas cones have got curves involved. However, for the purposes of the formulas we're using, cones work exactly the same way as pyramids. So the volume of a cone is still going to be the base area multiplied by the height. So looking at the first question, it can be difficult to figure out what the base area is given against perspective, but the base area of a cone is going to be a circle. Looks more like an oval from this direction, but if you looked at it from above, it would be a perfect circle. Now the measurements are on the outside of the shape, but the 12.2 in question 1, that is going from the edge of the circle to the centre of the circle, so that is the radius. And then the 10 meters, that is the height, and that is at a right angle to the base. So we're going to follow exactly the same formula and exactly the same method we use with pyramids. We're going to find the base area, And it's not going to be kind of length times width like it was with square-based pyramids. Cones are practically circle-based pyramids. So we have to find the area of a circle. So that would be pi r squared, which would be pi multiplied by the radius, 12.2, multiplied by the radius for a second time, or we could say squared. We can type that into a calculator and we should be getting 467 point. And we're going to round to one decimal place at the end, so I'm going to do my working out to about 4 decimal places, just so there's no rounding errors. So 5, 9, 4, and 6. And because pi is involved here, you're always going to get an endless list of decimals with no pattern. So we're just going to round to a few more decimal places than we need for our final answer. So our second step, we're going to take that number and multiply it by the height. And while you can do all of this on a calculator all at once, it is useful to show the step-by-step working you're doing, just in case you make a mistake, so the examiner can see everything that you've done and award you marks for your working out. So we're going to multiply by 10 for the height, and that should give us 4,675. And again, with decimal places, we're just going to write about 4 of them. So 9, 4, 6, 5. Then, for our final answer, we have to remember that we need to divide by 3. For these kind of pyramid shapes, we have a point at the top. So taking that number and dividing by 3 on a calculator, that's going to give us 1,558 point, and to one decimal place it will be 0.6, and our units were in meters cubed. Moving on to question 2. So start off looking at the shape, and as you will see we have a circular base, and we have at a right angle we have the height, which is 13 meters. So following our method, we're going to find the base area first. So for a circle, that'd be pi r squared, that'd be pi times 9 squared. These will always be calculator questions, and typing that into a calculator with the pi button, that will give you 254.4690. So again, just using more decimal places than what we're going to need for our final answer to stop any rounding errors. We're going to multiply that by the height, as we take our previous answer. We're going to multiply it by 13. And again, this is all going to be on a calculator, and you'll get 3,308.0970. So then we take that number, and the last step is always going to be we need to divide by 3, because cone and pyramid shapes are a third of the size of the equivalent prism or cylinder. And again, using the calculator, that's going to give me 1,102.7 if I'm rounding to one decimal place, and the units are meters cubed. Moving on to question 3. So identify the shape of the base. So we have a circular base. Identify the height, which is at a right angle to the base, and then follow through the formula. So the base area will be pi r squared for circle. So type pi times 12 squared into a calculator, and you should get 452. And then putting on some decimal places to stop rounding errors, 3,893. Once you've found the base area, we have to multiply by the height. So take the number we've just found, and I'm going to multiply it by 12. That should give you, on a calculator, 5,428. And again, use of decimal places to protect against rounding errors, 6,721. For our final step, we're going to take that number, and we're going to divide it by 3. And again, using the calculator, we should get 1,809 points, and then to one decimal place it's 0.55, so round up on a 5, it'll be 0.6, and the units will be meters cubed. Moving on to question 4. Again, identify the base of the shape. It's a circle. Identify the height, which will be at a right angle. Something to note here is, I'm just going to highlight another side here. Now this diagonal side of the cone, this often will have a label and it is not to be used. So again, the base and the height have to be at a right angle. Any other measurements may confuse you, so we're not using the slanted kind of half height, half width of the cone. So to find the base area, pi r squared for a circle. The radius is 14. Type that into a calculator. So that should give you 615. And then for decimal places, 7, 5, 2, 1. Take that number and multiply it by the height. That'll be multiplied by 10.8. And again, using the calculator, 6,650.1233. For our final step, we'll take that number and we'll divide it by 3. So for final answer, you should get 1,216. And then to one decimal place, it's 0.70, so that'll just be to 0.7. And the units, meters cubed. Now, moving on to the final question, you will notice that I've run out of space. And what I want to show you is it's possible to type all of this into a calculator at once. So, looking at question 5, we want to do the area of the base, so pi r squared. So that'd be 11.6. Then we want to multiply it by the height, which is 14.1. Now, if you do type all of that into calculator all at once, as long as your calculator can handle BidMass correctly, so it'll do the 11.6 squared first and do that in the correct order. And if you're not sure if it'll do that or not, then don't type in the squared button, do it times 11.6, times 11.6 for a second time. What you need to do is type all of that onto the exam paper. So every single button pressed in the calculator has to go on the exam paper so the examiner knows what you've done. So if you do make a mistake, they are going to award you quite a few marks. Now, the answer for question 5, you should get on your calculator, if this happens correctly, 1,986.8 to one decimal place, and the units cubed. What I suggest you do is that if you're not very confident, if a question is only asking for the volume of a cone or same thing with a pyramid, then do the full working out as I've shown you with the step-by-step. If you're feeling extremely confident, or perhaps you're working on a grade 8 or 9 question, and find the volume of a cone is only part of the question and there's other things to do, so you don't want to use up all your working out space on the exam paper, then you might want to do this faster method. Moving on to the hard questions, now we're going to look at the volume of spheres. Now there's a formula you need to remember for this, and the formula is the volume of a sphere is equal to, now there's quite a bit to this formula, so firstly we have a fraction, pi r cubed. Now, if you imagine that pi r squared gives you the 2D area, then pi r cubed will give you the 3D volume. So that bit makes sense. Why is it 4/3? Well, the answer to that lies in A-level maths. So basically, this is a formula you're going to have to remember and trust your teachers that it works. And then if you're interested, you can move on to A-level and find out how it works later. So what I suggest you do is for every question, write down the formula. So question 1, you got 4/3 of pi r cubed. Then underneath, I'm going to show my substitution. So we're doing 4/3 multiplied by pi, multiplied by the radius, which is 9 meters, and then that is cubed. If you type all of that into your calculator, then you should get 3053, and to one decimal place that'll be 0.6. So again, because pi is involved, we get an endless list of decimal places with no pattern, so we're going to have to round. And the units, that'll be meters cubed, because we've multiplied together 3 lots of 9 meters, so we've got a little 3. If you're not getting that answer, just be careful with the 4/3 bit. Either use the fraction button on your calculator to get 4/3, or alternatively, you can multiply by 4 and divide by 3 to get the same effect. Moving on to question 2. So again, write down the formula. So repeating this will help you to remember the formula, and also if you do this on an exam paper, then you're showing the examiner that you understand which formula to use. Then, showing substitution, and writing the substitution on the page is crucial. You're showing the examiner that you understand what the radius is and how to apply the formula. And the radius for question 2 is 6, so it'll be 6 cubed. And then for our final answer, we're going to have 904, and it's 0.77, so we're going to round up on a 5, so it'll be 0.8 meters cubed. So even though we're typing it all onto our calculator and doing it all in one go, we're still going to write things on the page for the examiner to look at, just in case you've made a mistake that proves your knowledge. Question 3, again, write down the formula to help you memorise 4/3 of pi cubed. Then we're going to substitute 4/3 multiplied by the pi, multiplied by, and the radius here is, now interestingly here, we don't have a radius in the question. So looking at question 1, we have 9 meters, which is halfway across the sphere. And we did that same length in the middle. We can see it goes from the center of the sphere to the edge. Then the next question, we've got 6 meters, which again will be from the center to the edge. But in question 3, the 12 meters goes all the way across the sphere through the center. So that's actually a diameter. And again, having diameters in place of radiuses is a really common way just to make sure that you know exactly what you're doing on these questions. So the radius is only going to be halfway across that measurement. And so half of 12 will give us a radius of 6. Now you might recognize that because actually it's exactly the same as question 2, and it's going to have exactly the same answer. It's just a different way of labeling the question. Moving on to question 4. So again, it's 4/3 of pi r cubed. I'm going to substitute into the formula. And then when we come to radius, we're going to be careful. We're going to double check what we've got. And in this question, we do again have a diameter. So our radius is only going to be half of that, which half of 16 would give us 8. So it'll be 8 cubed. Then we can type all of that into our calculator to get our answer. And that should give you 2,144. And to one decimal place is 0.66. We'll round up on a 5, so that'll be 0.7 meters cubed. And finally, look at the last question. Again, same formula, 4/3 pi cubed. We're going to substitute into the formula. We need to multiply by the radius. I'm just going to double check what that measurement actually is. And the 18.8, it goes all the way across, so that is a diameter. So we have to go halfway across for the radius. So half of 18 is 9, and half of 0.8 is 4. So it'll be 9.4 cubed. Again, this is something we're going to type into our calculator. And a little tip with formulas is what you can do is press the back button on your calculator and just delete the radius and then change the radius to something else, keeping all the other elements the same on the working out line of your calculator. Your final answer should be 3,000 479, and to one decimal place it's 0.14, so we're not going to round up on that 4, so it'll be 0.1, and again it's going to be meters cubed. So when you find the volume of a shape, usually you find the area of one of the faces, and then you multiply it by the height or the length, and then that's your answer for a prism. For a pyramid or cone, needs to be divided by 3. So all of those formulas are related to each other, but for the volume of the sphere, it's something a little bit different. So you've got something to remember and to substitute into.
Ouch! This is why in some videos I have unexplained scratches.